Hello and welcome to the Magic of Mathematics channel. My name is Manohar Murthy and you are watching one amongst a series of videos exploring the world of mathematics. In this video, I intend to intuitively explain how to construct a triangle given its three sides. I will assume here that you have a basic knowledge of the concepts of triangles and circles and that you know how to use a geometric compass. I will use an example to illustrate the construction. Let us assume that we have to construct a triangle with its three sides measuring 4 units, 5 units and 3 units. Here, when I say units, I mean any unit of measurement like centimeters or inches. First things first, we will need to verify whether it is possible to construct a triangle with these side measurements. For doing this, I will use the triangle inequality property, which states that the sum of any two sides of a triangle is always greater than the third side. Basically, we need to verify whether our side measurements satisfy the triangle inequality property. Let us do that now. Adding 4 and 5, we get 9, which is greater than the third measurement, namely 3. Similarly, 5 plus 3 equals 8, which is greater than 4. And 3 plus 4 equals 7, which is greater than 5. We see here that the sum of any two side measurements is greater than the third. Clearly, our side measurements satisfy the triangle inequality property. Hence, we can conclude that it is possible to construct a triangle with these side measurements. Let us now look at how to construct such a triangle. I will begin by constructing one of the sides. For this, I will pick one of the given measurements, say 5 units, and using a scale, I will draw a line segment measuring 5 units. It is clear that the line segment that I have drawn represents one of the sides of our triangle and the end points of this line segment represent two of the vertices of our triangle. We know that the remaining two sides of our triangle measure 4 units and 3 units and they have to be constructed starting from these two vertices. But the question is, how do we do that? If I draw an arbitrary line segment with one of its endpoints as this vertex and measuring 4 units and draw another line segment with one of its endpoints as this vertex and measuring 3 units, we can see that there is no guarantee that we will get a triangle. Clearly, we can't draw arbitrary line segments like this and hope to construct our triangle. So, what do we do? Let us now look at the problem in a different way. We know that we already have one side of the triangle and two of its vertices. Instead of trying to draw the two remaining sides, what if we try to identify the third vertex? If we can do this, we can join the third vertex to our two known vertices and we will have our triangle. For identifying the third vertex, we basically need to find a point which is at a distance of 4 units from one of our two known vertices and 3 units from the other vertex. If we can find such a point, we would have identified our third vertex. Let us now attempt to discover such a point. For this, I will make use of the fact that all points which lie on the circumference of a circle are at the same distance from the center of the circle and this distance is called the radius. Using a compass, I will measure a radius of 4 units and with this vertex as the center, I will draw a circle. I will then measure 3 units on my compass and using my other known vertex as the center, I will draw a circle. we can see that these two circles intersect at 2 points. Let us examine one of the points of intersection, say this one. Being a point of intersection of the two circles, it is clear that our point lies on both the circles. Because of the fact that our point lies on the first circle, and since the center of this circle is this vertex, its distance from the vertex should be equal to 4 units, as 4 units is the radius of the first circle we drew. By a similar logic, the distance between our point and this vertex should be 3 units. As we can see, we have discovered a point which is at a distance of 4 units from one of our two known vertices and 3 units from the other known vertex. We thus have our third vertex, and if I join this vertex to the other two vertices as shown, we will have our triangle. As a side note, the other point of intersection also satisfies the conditions required for qualifying as a third vertex of our triangle. I would also like to mention here that instead of drawing full circles, I could have drawn arcs instead, as an arc is a portion of the circumference of a circle, and hence the logic that I have presented would hold good for arcs as well. As we can see, using arcs results in a much neater construction and hence is a recommended construction method. In this video, I explained how to construct a triangle given the measurements of its 3 sides and also gave an understanding of why the method works. I hope you found this video useful. Thanks for watching.